Hi, I'm Keon, and in this video I'm going to show you a proof of showing that the sum of this geometric series converge to a certain number. So I'm not going to use the formula for geometric series, but I'm going to use the definition of limits and partial sums. So we know that partial sum is basically the sum of individual parts of series, and when taking the limit of a partial sum, we get the infinite series answer. So let's write the first few terms of a series. So we start by having 1 and then plus, and then we have 1/4 and then plus, and then we have 1/16 and so on. And so by writing a partial sum, we take the first number. So I'm going to write it as Sn. So it's the first number, 1. And then we have plus 1/4 plus 1 is 5/4. And plus, and then 5/4 plus 1/16 is 21/16. And then plus so on. And then now we can see a pattern. So we can see that what we want to find is a formula for the nth partial sum, and then in which we can take the limit. So we can see that for geometric series, there's actually a neat formula for finding a partial sum, where that's a1, which is the first term, which is 1 here, times, so here 1, times 1 minus r, which is the common ratio, or 1/4, to the power of n, over 1 minus r. So if r is 1/4, 1 minus r is just 3/4. So we know that this is the same as, again, I'm going to write again 1 minus 1/4, and then to the n, and then over 3/4. Okay, now you have a formula for the nth partial sum. And now what you have to do is that since you have the nth partial sum has kind of the individual sums of part of a series. And when we take the limits of the nth partial sum, we basically get what the value converges to, or what the series goes to. For example, if you try to find the partial sum for harmonic series, you won't necessarily find the kind of formula, but there is a neat formula that is kind of ln of n plus some constant gamma or lambda, and then since ln of n diverge, we can also say that the series diverge. And this partial sum method works for technically every series that we can find the partial sum for. And now if we use a different color, if we take the limits as n goes to infinity, because we want to find kind of the infinite sum, so we have to take the limit as n goes to infinity of s sub n. So we see that as n goes to infinity, this 1/4 to the n gets smaller and smaller, because it's 1/4 and then divides by a fourth, 1/16, 1/64, so it goes to 0. So we have 1 minus 0 over 3/4, which turns out to be 4/3. So the answer to our summation of our original sum, which we asked, should be 4/3. So this should be 4/3. And to just make sure that we're right, we can actually use the standard formula for the geometric series, which is a1, which is 1 over 1 minus common ratio. 1 minus 4/3 is 3/4, and that turns out to be 4/3. And we see that they have the exact same value. And so this is our answer. Thanks for watching. I hope you liked it. Please subscribe to my channel, and goodbye.